Because what we're doing in this section is multiplying.
Multiplying what?
Well, you tell me, what's this chapter about? Multiplying what? Polynomials. Okay, so we're going to look at multiplying some polynomials here. We're also going to look at a couple shortcuts that we can sometimes use. And we're also going to try to tie this back to what you did in 5th grade, which doesn't usually happen, but we're going to do that this time. Okay, so let's start by taking a monomial like 5x squared. It has only one term. And multiplying it by a binomial, negative 4x squared plus 3x minus 2.
Okay, so, sorry. You didn't ask anything yet.
Well, you might be thinking, what's different about that than anything else we've done? And the answer is nothing.
So you would distribute that?
Yep. All semester long, we've distributed the term outside the parentheses through the parentheses. We're going to do the same thing here. So you talk to me, 5x squared times negative 4x squared. What's that? That's right. It's negative 20x to the 4th. Class, how about 5x squared times 3x? What's that?
Would be 15x squared. I don't know.
Do you add exponents or do you add?
Right, which one?
That's the part that I'm looking at.
Class, you tell me. When I multiply, do I add the exponents or do I add them? I add them. That's right. Just like I've done all chapter. So it's going to give me 15x cubed.
Oh, okay. Now I'm with it.
And 5x squared times negative 2 is negative 10x squared.
Oh man, I knew that one.
I feel better when they're in descending order. It just, like, I feel like much better when they're in. I'm glad that they are, but it like gets me like off balance when they're not in descending order.
Don't let it throw you, Aaliyah.
Okay.
They're just terms. They're not going to bother you, even if they're not in descending order.
Okay.
Okay, so if one of them's a monomial, then life is not any different than it has been. What if one of them's not a monomial? For instance, what if we had 3m to the 3rd minus 2m squared plus 4, and we're going to multiply that by 3m minus 5.
I just don't remember how.
Okay.
Okay, hang on, don't say anything yet. Give people a chance to think.
Alright, Alright, call me when you get a chance.
No, don't call Brandy. Call somebody else.
I'm going to pause. That was to multiply polynomials, multiply every term in the first parenthesis through the second one. So we're going to take the 3m cubed through 3m minus 5. We're going to take negative 2m squared through 3m minus 5. And we're going to take 4 through 3m minus 5. Now if you're ahead of us, that's fine. Go ahead. Let the rest of us catch up to you. So here we go. 3m cubed times 3m would be 9m to the 4th. And 3m cubed times negative 5 would be negative 15m cubed. And I'm done with the 3m cubed. Now I'm going to take the negative 2m squared through. Negative 2m squared times 3m is negative 6m squared. Negative 2m squared times negative 5 is 10m squared. Done with the negative 2m squared. Let's take the 4 through. 4 times 3m is 12m. 4 times negative 5 is negative 20. I'm done with the 4, and I'm done distributing. And in a moment now, I'm going to combine the like terms with what I've got left. Okay, Sharisa, you had your hand up. Nikea.
Why wouldn't negative 2m squared times 3m, why wouldn't that be negative 6m cubed.
Okay, ladies and gentlemen, the question is, why wouldn't negative 2m squared times 3m be negative 6m cubed? And the answer is, it would be.
Okay, good, 'cause I was just about to ask that question.
Okay? Thank you for catching that. This should be a cube right here on the negative 6m.
That was actually great.
Where does the M4 come out on 9m to the 4th?
Well, I've got 3m cubed, and then this is 3m to the first, and when I add the exponents, I'm going to end up with 4 of them.
Alright, I wrote it down wrong.
Okay. So, sorry for the mistake there. Everybody good now?
Yes, sir. Yes, sir.
That's gonna be,
We're gonna be a
yeah, if I got it right.
Okay, now let's combine like terms. So I got 9m to the 4th. I've got negative 15m cubed and negative 6m cubed. What's that?
That's negative 21 and cubed.
Yes, negative 21m cubed.
Okay, we're going off to a good start. And slide all that down.
And then I got 10m squared. Don't have any other m squareds. I've got 12m. Don't have any other m's. And I've got 20. And that's what Brandy meant when she said slide all that down. The rest of that just came down because there's nothing to combine it with.
killing it over here.
And there we go.
Yay, me too, girl, that's how I feel.
So, Hannah, Caitlin, and Aiden, how are we doing?
Good, good.
Okay. Class, here, how are we
The
doing?
easiest thing we've done so far. Thank you. I needed this.
I just do what's on the syllabus. Okay, I don't have any control over easy or hard.
Good.
He said, see what's on the
Okay, now, I want to multiply a couple of binomials, and then I want to stop the lesson after that
like
for a little bit. Yeah. No, we're not leaving then. So if I take 6x minus 4, well, you guys just downright giddy all day today. Times 2x plus 7. Now listen, when I multiply two binomials, I usually do it just like I just did. I just distribute the 6x and distribute the negative 4. So that's the way I'm going to think first here. Okay, so here we go. You guys help me out. 6x times 2x.
12x squared.
12x squared. 6x times 7. 42x, and we're done with the 6x.
okay. You do it in a different order than I do, but we get the same.
Okay, we'll get to the same place. Let's do the negative 4. Negative 4 times 2x. Negative 8x, okay. Negative 4 times 7. Done with the negative 4, and I'm done distributing. And so we got a couple of like terms here. So I got 12x squared. 42x minus 8x, wouldn't that be 34x? And minus 28. So you've done that a lot in your life, right?
Yeah.
Now, perhaps you're already ahead of me on this, but when you multiply two binomials, that's when that acronym that you've learned in the past can come into play, the FOIL method. So you remember what FOIL stands for?
First order interval.
Yeah, this 12x squared came from multiplying 6x times 2x, which are the two first terms. The 42x came from multiplying 6x times 7, which are the two outer terms. The negative 8x came from multiplying negative 4 times 2x, which are the two inner terms. And negative 4 times 7 gave me negative 28, which came from the two last terms. So if you're multiplying two binomials and you like to think in terms of first, outer, inner, last, that's fine. I don't usually think that way. I just distribute both of them. But FOIL is obviously a acronym that you hear a lot in algebra, so we need to be a little bit familiar with it. Okay, so first, outer, inner, last. Now, here's my question to you. This is where I want to stop the lesson for a minute. So you can put your pens down if you want to even. I want to compare that to a 5th grade multiplication problem. So, and I want to pick the problem because certain numbers will illustrate what I want to illustrate easier than others. So let's say I had 32 times 23. Okay, and my 5th grade math teacher was Mr. Henry. So let's say I'm sitting in Mr. Henry's math class. Okay, so this is the method I was taught for multiplying. 2 times 3 is 6. 3 times 3 is 9. Do you guys put a 0, leave it blank, put a lightning bolt? What do you do? Answering. Okay, now here we go. 2 times 2 is 4. 3 times 2 is 6. And if we add 6 and 0 is 6, 9 and 4 is 13, and 6 and 1 is 7. And Mr. Henry told our class that an answer to a problem like that is 736. And we all took his word for it that that worked. And we went on to the next question. But here's my question to you. Why is that how you multiply? Why does that work? All that is it's some method. Methods in mathematics are called algorithms. Now, algorithm's a really big word right now. It's what Netflix is using when you punch on a show. It takes that data, throws it into an algorithm, and then makes suggested shows from that. All they're doing is throwing it into some formula, some method, some series of steps, and then it kicks out to you some shows. Kind of like a function, isn't it?
Yeah.
Gives the input and then kicks back output. So we're going to look at why this method that we learned in 5th grade, we're going to look at why it works here in just a moment. Aaliyah.
Oh, I was about to say that I heard that before because I think it was yesterday. I came here and the internet was down. They said something about like I think that same word was like the algorithm was messed
Yeah.
up or something.
Well, algorithms are really big right now because advertising has become personalized, right? So why is it that when I'm sitting in my home in Jackson, Missouri, and I punch in the St. Louis Post-Dispatch, and all of a sudden an advertisement comes up from some company in Cape Girardeau? Well, that company's, do you think that same company's going to pop up to someone who's looking at the St. Louis Post-Dispatch in Mount Vernon, Illinois, where my parents live? No, it's all based on algorithms, things I've clicked on, they've gathered data on, they know where I'm at, they know what output to give me, what advertisement to send. Okay, here's my next question to you. Does this in any way, okay, I'm not going to talk. I'm just not going to talk while you guys are talking. I'm just not going to. Because what I want to do is try to illustrate to you that what we did in 5th grade is really what we're doing right now. We just don't usually think of it that way. So what if I thought of 32 as 30 plus 2? And what if I thought of 23 as 20 plus 3? That's 32 times 23 right there. Okay? Now, what I'm going to do is I'm going to distribute the 30 and distribute the 2, just like I did up here. So here we go. 30 times 20 is 600. 30 times 3 is 90. Done with the 30. Let's distribute the 2. 2 times 20 is 40. 2 times 3 is 6. Now if you look closely, you'll see over here every one of these numbers. You'll see them all. This 600 is sitting right here. You say, that's a 6. What's in the 100 spot? It came from multiplying this 3 times that 2. But if you notice, both of those are in the tens place, so really we're multiplying 30 times 20. This 90 is sitting right here. It came from multiplying those two 3's. But really, this 3 is in the tens place, so really we took 30 times 3, just like we did over here. This 40 is sitting right here. It came from multiplying these two 2's, but that 2's in the tens place. So really, I took 2 times 20, just like I did right here. And then the 6 came from 2 times 3, just like I did back here. So what we did in 5th grade, all it was a method that did this for us. This is why 32 times 23 is 736. This was just a method that did that for us. Okay, so notice 600 plus 90 is 690, plus 40 is 730, plus 6 is 736. So that gives you at least something concrete that you're familiar with to tie what we're doing here to. It's the same notion. Aaliyah, you had a comment.
I figured myself out before, yeah. I
Okay.
see where I messed up.
So anyway, I've always found that kind of interesting and fascinating. Hey, you could come up with another method that would do this, that wouldn't have to look like this. I mean, in fact, there are other methods. If anybody learn lattice multiplication? Anybody ever learn that?
Yes.
Yeah, some of you. So anyway, okay. But all those methods are basically doing the same thing. Now, I said we were going to look at a couple shortcuts as well. So that's what's coming next. And the shortcut that we want to use next are for when we have some critters called conjugates. Now this is a word you're going to learn later in the class, so you might as well learn it now. Conjugates. So let me give you an example of a couple of conjugates. 2x plus 5 and 2x minus 5. So what do we got here? We got binomials. They're just alike, except for the sign in the middle switches. That's it. That's all conjugates are. We could make them all day long. I could say x minus 6, x plus 6. Those are conjugates.
So what makes them a conjugate is that the sign is different than the other.
That's it. That's the only thing. Now, we're going to have a shortcut here in a moment for multiplied conjugates. But look, I'd rather you figure it out for yourself than me tell you. So let's do these the old-fashioned way first and see what we get and see if we see a pattern develop. Okay, so we're going to do both of these. So here we go. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Done with the 2x. Let's do the 5. 5 times 2x is 10x. 5 times negative 5 is negative 25. Now, do you see that when I multiplied those two conjugates, the two middle terms canceled?
Yeah.
That's kind of an interesting result, isn't it?
Yeah.
And I end up with just 4x squared minus 25. And I'm kind of wondering inside my head if that always happens. If the middle terms always cancel. So why don't you guys multiply x minus 6 times x plus 6 and see if it happens again. And I'll catch up to you in a moment. So, hopefully, when you did it the old-fashioned way, you ended up with a plus 6x and a minus 6x in the middle. So they do cancel. And I end up with x squared minus 36. So if that's always going to happen when I multiply conjugates, then why don't we just make a shortcut and cut out that part? So here's the way I usually state the shortcut. I usually say when you're multiplying conjugates, to get the first term, take the first times the first, like 2x times 2x, to get the 4x squared. And then take the second times the second, like 5 times negative 5, to get the negative 25. Now, it only works when you got conjugates, so you don't want to try this when you don't have conjugates. It's going to lead you astray. But if you got conjugates, that's pretty nice. So, Anthony can't talk, never mind. Chrissy, can you give me a number, please? 4x. Aiden, give me a number.
6.
Minus 6 times 4x plus 6. So since those are conjugates, if we want to employ our shortcut, we could just go 4x times 4x. First times first is 16x squared. Second times second would be negative 6 times 6, negative 36.
Oh, that's cool.
So what do you like, the old-fashioned way or the shortcut?
I like both because they both are simple to me.
Okay. All right, so if you get those and you want to use a shortcut, fine. If you don't like the shortcut, that's fine too.
As long as we get the right answer.
Rock on. Rock all over yourself. Okay, and we've got one more shortcut to learn. And this shortcut is for squaring a binomial. How many terms does a binomial have?
Two.
2, okay. So let's try squaring one. So, Hannah, give me a number. I do not know what you said, Hannah. Try it again. I think you said 4. Okay. 4x and Nikea, give me a number.
6.
Plus 6. There's a binomial. Let's say we want to square it. Now, the only way I have to square this binomial right now is to think about what it means to square something. And that means to take it times itself, right? Itself. So really, the only way I have to do this right now, the old-fashioned way, is just to take 4x plus 6 times 4x plus 6. So let's do that. Let's do it the old-fashioned way. So we'll distribute the 4x, we'll distribute the 6. Here we go. 4x times 4x is 16x squared. 4x times 6 is 24x. Done with the 4x.
Wait a minute. Okay, can I pause you for a minute? So, I think I just did something wrong. Because I think I'm still stuck on the other thing that you did. Because I got 16x squared plus 36.
Well, if you did that, you didn't multiply it times itself.
Yeah, I know. That's where I was confused. But, okay.
You know what, though? If I had $1 for every time I'd seen that done, I'd have a lot of money. But
Really?
that's what we're trying to avoid.
Oh, okay.
Okay?
Well, I'll wipe that out of my memory then.
Okay. Let's distribute the 6. 6 times 4x is another 24x. And 6 times 6 is 36. So when we combine like terms, we actually end up with 16x squared, which Aaliyah, you got that.
Yeah.
We got a 36 on the back end, you got that. But we also end up with a 48x in the middle.
Right, okay.
Now let's stop and think about that. This time, instead of the middle two terms canceling, they were the same. See that? They were the same. I wonder if that happens every single time. Chrissy is saying yes. Do we want to try it one more time and see if it does?
Yeah, it does.
Okay. Then let's do it this way. Let's see. I don't know. Let's go to a different color. We can't get stuck in the same color. I'm just going to go with X. And Caitlin, give me a number.
5.
Okay, let's go with a -5. And let's square it. Yes, ma'am.
Okay, so when you are adding like 24x and 24x, it will not be, the answer will not have an x squared, right?
That's right, because you're only going to add the exponents when you multiply.
Okay,
And we're not multiplying there.
okay.
Okay, so if we use the same old song and dance here, that means we're going to take x minus 5 times x minus 5, which will give me x squared minus 5x minus 5x. Almost. There you go. Plus 25. So did the same thing happen or not?
Yes.
It did. We got the same thing twice. So we end up here with an answer of x squared minus 10x plus 25. Okay, now what we would like to do is we'd like to develop a way to go from the problem to the answer in one step, since we're seeing the same pattern repeat itself. And you guys are going to help me come up with a way to do that. Okay? So, let's think about this top problem first. Can you tell me, class, where the 16x squared came from? 4x times 4x. So we could get that by taking the first times the first. First times first.
Oh, wait, hold on, I see your head in here. No. I think.
Okay, can I pause? Okay.
I don't know if
Let's skip number 2 and go to number 3. We'll come back to number 2 in a minute. So the question is, where's the 36 come from? 6 times 6. So we're going to take the second times the second. Okay, now I'm going to try to repeat Brandy's words because they were pretty good. Where do these 24x's come from?
4 times 6.
Yeah, the 4x times the 6, except we're always going to have it twice. Always going to have it twice. So we could take the first times the second and then take that times 2. And that always give you the middle term. So let's see how it could have worked on this bottom problem then. Okay, so here, let me see if I can erase all this. Hey, I can. Woohoo.
You didn't know you could erase something?
Well, sometimes it gets persnickety.
Oh.
Okay, so if I follow this shortcut here, first times first, x times x is x squared. That's good. First times second would be x times negative 5 would be negative 5x. Then take that times 2, negative 10x. Second times second is negative 5 times negative 5. That's 25. There it is. So let's try the shortcut on a problem or two. Okay, so I need a pair of people to volunteer on this problem. Okay, Aaliyah's gonna volunteer. How about, okay, Chrissy's gonna volunteer. Logan, give me a number.
Wait, any number.
Yep.
Okay.
Don't make it too hard, because they don't want ridiculous numbers to work with.
Okay, 6.
6x. Aiden, give me another number, please.
13.
See, he's making it hard.
I was getting
He's
up
making.
20,
Hey,
but
Aiden, let's go single digit number, Aiden.
Okay. -7.
Okay, -7. So let's say we wanted to square 6x minus 7. So Chrissy and Aaliyah's who we're talking to here. Tell me how I'm going to get the first term. Okay, 6x squared, she said. 6x times 6x, first times first, would give me what, class? 36x squared. Very good. Now, how am I going to get the middle term?
First on the second.
First time, okay. So what is the first times the second? 6x times -7 would be what?
42.
-42x. And then do what with that?
Times 2.
What's -42x times 2? -84x. Okay, and then how are we going to get the last term? How did you get it? -7 times -7 indeed is plus 49.
I forgot about that.
Okay, so do you guys like the shortcut or do you like doing it the old-fashioned way?
Old fashioned.
Okay, here's what, in this class, really the old-fashioned way is fine. If you take college algebra, learning the shortcut will be beneficial to you because there's quite a few times there that you square binomials. But in this class, if you like the old-fashioned way, it'll serve you just fine.
Okay.
Okay.
It's just the negatives.
Yeah.
That's what flipped me out. I was positive 84. I had it, but
Okay, class, your question, thoughts, or feelings?
is this all that's something hard? Is there anything else?
This is
You know what? This is what it is. That's the whole ball game. That's the whole shooting match. That's the whole kit and caboodle.
I like that caboodle.
Here's your page 299, class.
I'm ready.
I think I should cut this down some, so I'm going to. Let's go 6 through 24, and there let's go every third. It did just say 6 through 24 here on this paper. 43 through 50 are all conjugates, so you can either do it the old-fashioned way or use the shortcut. What was my deal on that? 57 through 60 are all squaring binomials, so you can either use the shortcut or do that the old-fashioned way. And then let's go 89 through 92. And you know I don't do this very often, don't you? I think we're going to shut it down there for today. And I hope that your spring break is safe and good.
Well, thank you.
Yes, Aiden.